Hello and welcome to my video on finding critical points. So first of all, I want to go through what critical points are. I found this picture online. Okay, so for finding critical numbers, two things that are very important is the derivative is equal to 0 and the derivative is undefined, C in domain of f, and you use the quotient rule to find f prime of x, the derivative. Okay, so what we're going to do is we need to find where the derivative is 0. So we're going to take the derivative of this, and we're going to use quotient rule, or when it's undefined. Okay, so first off, we have this is our original, and we take a derivative. The bottom. Okay. Because the derivative of e to the power of x is unfortunately, it's the same thing. Okay, and then we take the bottom and we square it. So it's, okay, now what do? We simplify it a little bit more, and then we get, now we substitute that, and x minus 1, square that. Now we get e to the power of x minus 2, x minus 1 squared, that stays the same. Okay, ignore this for now. We have to, okay, the derivative is undefined when the denominator is 0 at x equals 1, which is not in the domain of h of x. So we set the numerator equal to 0 to find where the derivative is equal to 0. So we set e to the power of x minus 2 equal to 0. Since e to the power of x never 0, we just do x minus 2 equals 0, and then we get x equals 2. So, when we look over here, where does h have critical points? X equals 2. That is the correct answer. So, basically, the critical point is at x equals 2, as that's where the derivative is equal to 0. So we take the numerator, and then we set it equal to 0. So now x equals 0 and x minus 1 are not critical points. X equals 1 is not in the domain of the function, so it is not a critical point. So the critical point is at x equals 2. Okay, I think I sped through that pretty quickly, so since I have like a minute left in this recording, let's just go over quotient rule. Okay, in this one, we take the derivative of the numerator, then we leave the bottom as is, minus the numerator is the same, and then the derivative of the bottom, and then we do the bottom squared. Then, basically, we have to combine the numerator, and, well, x minus 1, and you subtract 1 again. Like, since these both have the same, they have like common, they have e to the power of x in common, you can just change this into negative 1. It's like overarching. So you would do x minus 1 minus 1, and that'd be x minus 2, and then, yeah, you would use the numerator and set it equal to 0, since this is the derivative form, and then you set it equal to 0 because you need to find where the derivative is equal to 0 or undefined to find the critical points of h of x. And so we set that equal to 0, and then you get rid of e to the power of x, and then finally you get x equals 2. I hope that helps, and thank you for watching.